I think regarding crystallography, am I right? Yes or no? In that crystallography, what and what we discussed? Any idea? Don't turn. Just think and say. I'll give sufficient time. Don't see and read. By seeing, all will say. Already you got some knowledge. Am I right or not? What? What is the knowledge that you got in that session? Lattice point, space lattice, basis, crystal structure. Am I right? Yes or no? Uh, 7 crystal systems, 14 Brevis lattices. Yes, sir? Next, number of atoms in the unit cell, coordination number, packing fraction of simple cube, BCC, FCC. Experiment knowledge, these things I discussed. I don't know with whom I discussed, but only experimental verification that is left to Bragg's law, Lewis method, powder method. Okay. Now, from that entire unit, what we can conclude from the discussions that we made, what we can say, what we can conclude? Any idea? No idea? Here. What is the full form of simple cube? One more thing, primitive cell, unit cell also we discussed, lattice parameters also we discussed. Yes or no? Right. So, what is the conclusion that we can give from those topics? No conclusion. ఏమైనా ఉందా కంక్లూజన్ ఉందా? ఏమీ లేదా కంక్లూజన్. ఏమీ లేదా? సే సంథింగ్. Simple cube, BCC, FCC, in what way they are different? In what way they are different? Simple cube, BCC, FCC. Yes, good. Stand. Trying. One girl is trying. Amma, cheppamma. Right. In terms of free space that is present in the crystal. Means in terms of atoms. Opposite. In terms of atoms. The number of atoms are same in simple cube, BCC, FCC. Same or different? How many atoms are there in the simple cube? Choose the correct answer. 1, 2, 3, 4. I will say question, I will say answer, you select. Okay? Number of atoms of the unit cell of a simple cube. 1, 2, 3, 4. Thank God. BCC? Again 1, 2, 3, 4. So multiple options. 2, 3. 2 or 3, a correct answer. 2. FCC? FCC? 4. So this clarity is there. Coordination number means? Coordination number, exam point, it is important. Coordination number, number of equidistant atoms. Simple cube, how many? In simple cube, how many atoms are there? Speak louder. 6. BCC, body centered cubic crystal. With respect to center of the body, I am giving you hint. 8. With respect to FCC, 4. 3 planes. Each plane 4 atoms. Total 4 plus 4 plus 4. 12 atoms. So packing fraction of simple cube around 52%. BCC 68. FCC 72 or 74 something. Example for simple cube, polonium. Example is polonium. Why? Because idea purpose I am saying all those things. Okay, right. So in today's class we are going to see another topic, dielectric materials. Dielectrics. Dielectrics. Have you heard about this word? ఎప్పుడైనా విన్నారా? First time you are listening. Dielectrics. No. But I can say that its application is used, and that application, you know. Let us take one example. Okay, say one example I'll tell. Overhead tank, you know. Overhead tank. What is overhead tank? Where it is used? Water tank. Overhead tank. Okay. Paina undedi water tank. Every water tank has got some capacity, am I right? Water tank capacity untunda? Water tank ekkada untundi? Prati inti paina untunda? Every water tank has got capacity to store water. But let us say in terms of value, ఎంత అనుకుందాము? ఒక 500 అనుకుందామా? Or 1000 liters. Now, any possibility is there to store more water than 1000 liters in the same tank? Possibility is there? If you try to pour extra water, what you are going to say? Water ఏమవుతుంది? ఉండే ఓవర్ఫ్లో అయిపోతాయి. ట్యాంక్ ఫుల్ అయిపోయాక ఇంక ఎక్సెస్ వాటర్ దానిలో పోస్తే అందులో ఉంటున్నాయా, బయటికి వెళ్ళిపోతావా? Without changing the dimensions of the tank, we have to increase the tank capacity. How? Some material like arrangement, if you dip, and what is the material? It must absorb some amount of water. Then there is a possibility, okay, like that. You know, fan has got RPM. What is the meaning of RPM? Rotations per minute. Suddenly the fan RPM is decreased. Suddenly you switched on every day with some RPM. Ante generally we used to say speed antam kada. With some speed it is used to rotate. But suddenly one day the speed of the fan has been decreased. RPM has been decreased. So what you will do? Immediately you will change the number. Where you are going to change the number? That one is called as ఏమంటాం దాన్ని? If you want more speed or more RPM, ఏం చేస్తాం? What we use? Specs boy, please. Feel great to speak by standing. Regulator. ఏం చేస్తాం? What we do with the regulator? We change the number so that RPM of the fan is going to change. Antena? You change it there also. You change it numbers. No change. Then, yes. Next, what you are going to check? Good. Capacitor. What you are going to check? Capacitor. How many of you seen capacitor? Raise your hands. Sir, na capacitor చూసాను sir. Not seen. Okay, right. Anytime, if you remove the top cover from the fan, a cylindrical shaped white in color small component is there. Yes or no? చూసారు ఎప్పుడన్నది? What is shape of the capacitor that you seen? Cylindrical shaped. What is the color? Around white or violet, or made up of either plastic or some aluminum like foil. Yes or no? What it is? Searching. Then what it is? Capacitor. For what purpose capacitor is there? If RPM decreases immediately, if you replace new capacitor, RPM is going to increase. So what is capacitor? Generally, what is capacitor? Which stores energy. Which stores energy. What is symbol of capacitor? Say in words. Say in words. What is symbol of capacitor? Two parallel, two parallel, two parallel racer. Two parallel. No, no, symbol. How you are going to represent on paper? Symbol of a capacitor you draw means what you will do? Two parallel lines of equal magnitude. I can use the word magnitude. Equal magnitude means equal length. That is the symbol of a capacitor. If you draw unequal length, that is symbol of a battery. The difference you know now, right? Right. So capacity, sorry, capacitor. You know this even one type of capacitor you seen, many types of capacitors you seen in terms of applications. Bore motor, you know, bore motor. Generally 1 HP motor, 1.5, 2 HP like that, depending upon the number of floors, depending upon the depth of the bore well, motor is used. Yes or no? Avuna? There also one box is used, starter box. A name is given. Starter box అని అంటారు కదా. Did you open it and seen in it? ఎప్పుడైనా ఓపెన్ చేసి చూసారా? ట్రై చేశారా? స్టార్టర్ బాక్స్ చూసారా? ఇంట్లో బోర్ ఉందా లేకుంటే వెల్ ఉందా? వెల్ అంటే తెలుసు కదా. ఇంట్లో బోర్ ఉందా, వెల్ ఉందా? వాటర్ కావాలంటే ఏం చేస్తారు? సీస్కెళ్ళి ఒక బటన్ ఉంటుంది. గ్రీన్ బటనా, రెడ్ బటనా? గ్రీన్ బటన్ ప్రెస్ చేస్తారు, అంతేనా? ఎక్కడ ప్రెస్ చేస్తారు గ్రీన్ బటన్? దానికి ఒక సపరేట్ బాక్స్ ఉంటుంది. బోర్కే ఉంటుంది గ్రీన్ బటన్, ఓ బాక్స్ ఉంటుంది. బాక్స్ని ఏమనాలి? స్టార్టర్ బాక్స్ అనాలి. దాని ఏమంటారు? స్టార్టర్ బాక్స్ అంటాం. స్టార్టర్ బాక్స్ మీద ఏమేమి ఉంటాయి చూసారా? వాట్ ఈస్ గోయింగ్ టు ప్రెజెంట్ ఆన్ ద స్టార్టర్ బాక్స్? ప్రతి ఇంట్లో బోర్ ఉంది. రెగ్యులర్ కాకపోయినా అప్పుడప్పుడన్నా దాన్ని టచ్ చేసి ఉంటారు. చేయలే అమ్మాయిలు మీరు కూడా? ఇంట్లో ఎప్పుడు మీకు పని చెప్పరా? హాస్టలా? స్టార్టర్ బాక్స్ చూసారా? ఏమేమి ఉంటాయి చెప్పండి దానికి. ఏముంటవి? కొంచెం ఆలోచించి చెప్పండి. ఎస్, లౌడర్ యూ స్పీక్. హూ సెడ్ దట్ ఆన్సర్? స్టాండ్. ఫీల్ గ్రేట్. గట్టిగా. కనిపించేవి. వాట్ ఈజ్ విజిబుల్? దట్ ఐఎమ్ ఆస్కింగ్. విజిబుల్ అంటే తెలుసు కదా. సే వాట్ ఈజ్ విజిబుల్? ఎలక్ట్రానిక్ కాంపోనెంట్స్, రెసిస్టార్స్, ఐసీస్, ట్రాన్సిస్టర్స్, మదర్ బోర్డ్, సచ్ థింగ్స్ ఆర్ విజిబుల్ ఆన్ ద బోర్డ్. కనిపిస్తున్నాయి ఇక్కడ. వాట్ ఈజ్ విజిబుల్? దట్ యూ స్పీక్ ఫస్ట్. ఆల్వేస్ మేక్ ఏ హ్యాబిట్ ఆఫ్ స్పీకింగ్ వాట్ యు సీ ఫస్ట్. ఎప్పుడు కానీ మనకు కనిపించేది ఫస్ట్ చెప్పాలి. వాట్ వి సీ విత్ అవర్ ఐస్, వీ హ్యావ్ టు స్పీక్ అబౌట్ ఇట్ ఫస్ట్. ఆఫ్టర్ దట్ వాట్ ఈస్ నాట్ విజిబుల్ బట్ విచ్ ఆర్ యూస్డ్, దోస్ థింగ్స్ వీ హ్యావ్ టు స్పీక్. ఇట్ ఈస్ హ్యాబిట్. సంథింగ్ సమ్టైమ్స్ డిస్క్రైబ్ అని అడుగుతారు. డిస్క్రైబ్ జనరల్గా ఇంగ్లీష్ వస్తుంటుంది. హౌ యూ ఆర్ గోయింగ్ టు డిస్క్రైబ్? నోన్ టు అన్నోన్, విజిబుల్ టు అన్విజిబుల్. బట్ డైరెక్ట్ అన్విజిబుల్ రాస్తే ఏమవుతుంది? లెంత్ ఆఫ్ ద మ్యాటర్ ఈస్ గోయింగ్ టు డిక్రీస్. ఇఫ్ యూ వాంట్ టు ప్రొలాంగ్ ఇట్, ఇఫ్ యూ వాంట్ ఎక్స్టెండ్ ఇట్, ఏం చేయాలి? యూ స్పీక్ వాట్ యూ సీ ఫస్ట్. లేటర్ ఆన్ యూ స్పీక్ what are used. So what is appearing on the board of a starter box? కనిపించేదే. కొంచెం ఆలోచించి చెప్పండి. 2 మీటర్స్ ఉంటుంది. 2 మీటర్స్ మ్యాక్సిమం 2 మీటర్స్ ఉంటుంది. వాట్ అండ్ వాట్ దే ఆర్ నేమ్డ్ యాజ్ ఏ అండ్ వి. ఏముంటుంది అక్కడ? ఏ ఉంటుంది, వి ఉంటుంది. ఐ డోంట్ నో వెదర్ యూ నోటీస్డ్ ఆర్ నాట్. A stands for ammeter, V stands for voltmeter. Ammeter measures current, voltmeter measures voltage. Generally, what is the voltage that we get from the socket? Enta voltage? around 220, 230 plus or minus some percentage. So whether 220 or 230 voltage is there or not, if you press voltmeter button, it will show. Yes or no? Right. How much current when you run the motor, depending upon the wattage, some current it will show. 6 amp, 8 amp, 10 amp, 12 amp like that. Okay, that is visible. But anytime, if any problem comes with the starter, if water is not coming, the technician will come and he will open it and see. What is there inside? Inside ఎప్పుడైనా చూసారా? Inside of the starter ఏముంటాయి తెలుసా? There also two cylinders will be there. Cylindrical shaped things. Those cylinders size, when you compare with the capacitor, this will be same. No. This capacitor is small in size. Those capacitors are big in size. Generally some numbers are given. Okay, some numbers. So people, that electrician, mechanic will remember that so and so number used for so and so motor with so and so wattage. What I am saying following. So why I want to say all these things, because we have got different capacitors. Yes, searching for busy. Any part-time job is there? Then morning, why? Right, we have got different capacitors. The capacitor that is used for fan, the capacitor that are used in motors are not same. Means what I can say, the energy stored is same or different? It is different. Where more wattage, the electrical gadgets which need more wattage, corresponding capacitor will be used. Means what I can say, that every capacitor has got some capacitance. Am I right or not? Every capacitor has got some capacitance. What is the meaning of capacitance? Just now I gave examples. The energy stored in different capacitors, it is different. Okay, this capacitor's energy, the capacitor that is used in borewell, energy will be same, because bore will need more current, less current. Bore motor needs 1 HP motor, 3 HP motors. If you take those two examples, which will consume more amount of current, 1 HP or 3 HP? So the capacitor that is used also will be same or different? Motor as well as fan. This is 220 voltage, very less. What is the wattage of this electric fan? How much? Sir, what is my question? Not here. Stand. Just now I took one example. What is that example? Black shirt, you also. Giving company. You won't change. అలవాటు కదా? Sit. Feel shame or feel good? You decide. Standing in the class, especially. Right. What I was saying? Different capacitors, capacitance will be same or different? It will be different. The sizes are different. Or sometimes same size, different capacitors, capacitance also we can see. How? Same size capacitors will have different capacitance, means different amount of energy it is going to be stored. How it is possible? For that purpose, we use this concept, dielectric materials or dielectrics. Okay, dielectrics. What are these dielectrics? These are the materials which are used in capacitors to increase its capacity without changing the dimensions of a capacitor. What is the formula for capacitor? C is equal to epsilon naught A by D. Expression for capacitor, C is equal to epsilon naught A by D, where epsilon naught permittivity of free space, A area of cross section of the plates that are used inside the capacitor, D distance between two plates of a specs by. What is D? Stan, what is D? What is D? What is A? A for apple. Then of plates. Where these plates are used? Good. Okay. Now C dash is nothing but K times C, means same capacitor with a different capacitance. So that whose capacitance will be more, C dash or C, C prime or C, which is equal to K into epsilon naught A by D. So how many times the capacitor's capacitance has been increased? K times. What is this K? K is nothing but called as dielectric constant. What is the name given to K? Dielectric constant. Means the material that is used inside the capacitor to increase its capacitance, that material's dielectric constant is K. Different materials are there. Okay. What unit of capacitor? What unit of capacitor? Farad. What unit of capacitor? Farad. Who proposed? From Faraday. Okay. But the capacitors that are used in our daily life applications, whose unit is not Farad, but it is how much, microfarad, millifarad, microfarad or millifarad, because this is the biggest unit, largest unit. The capacitors that we use inside fan, inside a starter of a motor or other places where capacitors are used, if you see, complete details will be there on it printed. If you observe 0.01 microfarad, 0.05 like that, number, decimal number with units. So if you observe that unit, micro or millifarad will be there. Means that much capacitors, that much is enough. Okay. Farad is the biggest unit. Farad is the biggest unit of capacitor. Okay, right. Now, so capacitor's capacity we can increase without changing the dimension by using dielectric materials. What? Dielectric materials. So what are dielectric materials? What are dielectric? One of the example for dielectric material is bakelite. I don't know, sir, వీళ్ళకి ల్యాబ్ సిలబస్ ఏమున్నాయి సార్ ఫిజిక్స్లో? ల్యాబ్ ఉందా? ఫిజిక్స్ ల్యాబ్ ఉందా వీళ్ళకి? అందులో బెకలైట్ ఉందా? డైఎలెక్ట్రిక్ కాన్స్టెంట్ మీ దగ్గర అక్కడైతే ఉంది. ఓకే, లెట్ ఇట్ బి సార్. Right, one of the material that is used, bakelite, which is black in color, has got some thickness, different thickness, which is used as a dielectric material. It may be in solid form or liquid. Right. So finally you got some idea that dielectric materials are used in capacitors for increasing its capacity. Means same dimension capacity can hold more amount of charge, less amount of charge, more amount of charge. So that is simple answer for the dielectric material application. Okay, actually what are dielectric materials? Generally these dielectric materials are also called as insulators or insulating material, I can say. Very less amount of current and no current it is going to flow. Very less or no current the body is going to allow, the material is going to allow. Means they are called as insulators. Then why are you bending your head like this? If you bend like this and sit, means what it indicates? Sir, corner boy. I am disturbing you? Yes. What are you doing? Don't nod, say in words. Okay, corner boy, please. Please tell me about this. What is this? Insulators. Speak about insulators. Uh, where did you heard this word? Inna eppudanna? What are insulators? What are insulators? Busy in mobile using. What are insulators? Yes? Less amount of current is passing, not passing. Means current pass, no current does not pass. So the materials which allows current, which does not allow current, they are called as, the conductivity will be how much? 0. No current is passing. So conductivity is 0. Okay, na? Our resistivity is, opposite of conductivity is resistivity. Resistivity is high. Okay. So insulators are bad conductor of electricity, I can say it. Why? Because there are no, actually for conduction, what is necessary? How conduction takes place in a body? How conduction is going to take place in a body? Because of, when a current is going to flow through a body, that is my question. Conduction, current, what must be there in the body? With the help of what the conduction takes place? What is a body is made up of? Atoms. Atoms are made up of molecules. Molecules are made up of atoms. Atoms are made up of electrons, protons, and neutrons. So electrons, for what purpose they are used? They are used in conduction purpose inside the body. If the number of electrons are more, free electrons are there. Where free electrons are more, such bodies are called as conductors. Where free electrons are very, very less, insulators. The conduction is taking place because of free electrons that are present in the substance is responsible. Conduction is a surface phenomena or internal process. Current passes through surface of the body or through inside the body. Surface phenomenon it is. Okay. So electrons are responsible. Okay. In insulators, those electron number very, very less, or no free electrons, I can say it. Okay, na? Right. Now I can make a comparison between these insulators and dielectrics. I can make a comparison that between these insulators and dielectrics. I am saying that dielectrics are insulators. I am saying that dielectrics are insulators. Insulators means what? Which does not allow current. But dielectrics, just now we said, where dielectrics are used? In capacitors. For what purpose? To store the energy. Means where these dielectrics are kept? Between the plates of the capacitor. And when the capacitor is going to store charge? By passing current. Means it is allowing current, it is not allowing current. Then insulators. So in what way they are different? Means that I can say in terms of polarization, the difference. And one more thing what I can say, that dielectrics are insulators, but insulators are not dielectrics. One statement I can say, that all dielectrics are insulators, but all insulators are not dielectrics. See, one way it is correct, but other way it is not correct. Means one way, when there is no electric field applied, dielectric material is an insulator. But if you take insulator, if you apply electric field, it allows current? No. So, all insulators are dielectrics, but all dielectrics are not insulators. Example is vacuum. Let us take an example, vacuum. What is vacuum? It is a conductor or insulator? It is an insulator. Okay, vacuum, does it have any atoms, molecules, ions, etc.? Nothing is there, vacuum, empty. Okay. So, that is an insulator. When this insulator is kept in the electric field, polarization takes place? No. Okay. Right. So, dielectrics are insulators, but all insulators are not dielectrics. Why? When a dielectric is said to be insulator, or in what way an insulating body and dielectric body is going to different? Nothing but that I can say in terms of polarization. You must know polarization. Polarization takes place in dielectric materials. Polarization takes place in dielectric materials, but not possible in insulating materials. What is the meaning of polarization? Actually, you studied polarization in light also. One sidedness of light is called polarized light, or light has got two types of vibrations. When this light is allowed to pass through polarized state, one dimension, one vibrational, one of the vibrations are going to be blocked, only one vibrations are allowed. That one light with one vibrations we call as polarized light, we used to set it. Okay, that is different. Here polarization is nothing but formation of poles, formation of poles, nothing but poles, nothing but charges, positive pole, negative pole, positive charge, negative charge, positive charge, negative charge, where inside the body positive and negative charges are going to form inside the body. When external means forming is nothing but what actually, what is happening inside the substance, that you must know. Generally every substance, if you take a solid, external field is 0, every solid is made up of atoms. So, what is shape of the atom generally? Atom is spherical in shape, is that no? And what is atom is made up of? Electrons, protons and neutrons. Electrons, protons and neutrons. So, where we find this electrons, protons and neutrons in an atom? The arrangements of electron, proton and neutron. However, the arrangement of electrons, protons and neutrons, different theories is studied. Thomson model, Rutherford model, Bohr model, studied or not in the previous classes, secondary physics. So, finally, what is the conclusion that you can give regarding the arrangement of atoms? You wrote electronic configuration. Chemistry is there. In that chemistry and electronic configuration topics are there. What is the meaning of electronic configuration? One answer by standing. Electronic configuration means what? Simple words, distribution of in different atomic orbits, orbitals, orbitals. Where we find these orbitals? In orbits. What are the orbitals? S, P, D, F. So, distribution of electrons in S, P, D, F we call as. So, where these electrons, where these orbits are present? Where these orbits are present? In the form of circles drawn. Where the circles are drawn? Center what is there? Plus. So, nucleus surrounded with the orbits. Orbit contains electrons, means nucleus is surrounded with the electrons. Yes or no? So, electrons are part of the nucleus? No, they are orbiting around the nucleus in different shells, orbits. Okay. So, what is nucleus is made up of? Protons and neutrons. And how many number of protons and how many number of electrons will be there in an atom? Equal number, unequal number? Equal number. So, that is why what we say about the atom, it is a neutral Atom is charged particle or neutral? Atom, it is neutral, contains equal number of protons and electrons. Okay. So, protons are kept at the center of the nucleus and electrons are orbiting around the nucleus. Yes or no? So, electron is orbiting, assume one circle, that circle center will be where plus charge is there only it will be there or some other place? అక్కడే ఉంటుందా వేరే some other place you can find it? Center of electron will be near the plus point only or not? And this plus is made up of what? Nucleus is nucleons. So, center of electrons and nucleus point same or different? Coincided. Now, what I do in this body? I will apply some electric field. Where this body is kept now? External electric field E. Then what we are going to notice? The center of positive and negative charge is going to separate. Positive charge will move in the direction of field. Positive charge is going to move in the direction of field when external field is applied. Before applying, coincided. After applying, separation. Positive and negative charges are separated. Now, how many charges are there? 2. 2 means di. Charges are called as poles. So, what I can say it is dipoles. Where we find these dipoles? Inside the body. When we find the dipoles, when external force, external electric field is applied. If this is taking place, they are dielectrics. If this is not happening, they are insulators. And this is nothing but separation of charges, poles, creation of poles, polarization, we can say it, simple words. Okay, some technical terms are there, that also we are going to say it. Now, how much separation we are going to see between these? How much separation will be, or the separation depends on what? Yes, back. Where we find this? In which bodies? In which bodies we find this? You are there, you belongs to this class or some other class. Then why you sat here? Why I drawn here? Time pass. Sit. Feel great. No? Not only you, many. Nodding head, you know. So, where we find this? Dielectrics. Where it is going to be absent? Insulator. That is why when we find this in dielectrics, when external field is applied. If there is no external field, this is situation. This is also there in compared to insulators. So, that is why all dielectrics are insulators, but all insulators are dielectrics. In all materials, it is not going to express. Where it is going to express, such materials we call as dielectrics, dielectric materials. So, when external field is applied, charges are going to be separated, dipoles are going to form. What we say? Dipoles, electric dipoles. One is positive charge, the other one is. Now, this dipoles has got some separation D. Some separation is there or not? How much separation? When the separation took place? When we applied external field. Now, this E is responsible for D, yes or no? I want to change the D. I want to increase the D. So, what I can do? What I can do? Yes. What I have to change? When the D took place? Because of E. E is responsible for D, yes or no? If there is no E and a D is there, 0. Because of E, D is there. I want to change the D. So, what I have to change? E, strength of the field. I have to change the strength of the field. If I increase the strength of the field, separation between the charges is also going to increase or not, right. Now, every charge, positive charge or negative charge is E and separation is D. Separation between the charges D. This product is called mu. We gave a new name for the product of charge and separation between the charges, that we name as mu, and this mu is called as dipole moment. What we say? Dipole moment or electric dipole moment. What is electric dipole moment? It is a product of charge and distance between the charges. What about the unit of electric dipole moment? Unit of charge. Charge is expressed in unit of charge. Unit of charge. C. C stands for coulomb. Unit of charge is coulomb and D is meter. Coulomb meter is a unit of mu, called as dipole moment. Okay. Right. This will takes place in a particular atom or entire atom? Entire substance. Entire substance. Dipole moment we are going to see when external field is going to be applied. And one more thing I can say, based on this, these are called poles. Formation of poles, the presence of external field. Absent means these are where these poles are going to form polar substance, we can say it, and this is non-polar substance. In the presence of field, dipoles are formed polar substance, non-polar, that also we can say it, classification. Okay, right. So dipoles, two, di means two, charges means two poles, and the charge strength, when you multiply with the separation, then we get a dipole moment. Indicate with unit of dipole moment is not visible. Where is the circle? Double tap, pen, right. So dipole moment. Okay. Next, after this electric dipole moment, permittivity. Permittivity is indicated with the letter epsilon. What it is? Epsilon. It is a medium property to allow the electric line of forces. Medium property to allow electric line of forces, that will be expressed in terms of permittivity. There is an expression for permittivity which is equal to d by E. The expression for permittivity is d by E. We can also say that how easily no, how easily the medium is going to be polarized, that will be expressed in terms of permittivity. For free space or air, indicate with letter epsilon naught, whose value, calculated value is 8.85 into 10 power 12 farad per meter. One more unit is also there, just 1 minute. Coulomb square per Newton meter square, another unit is Coulomb square per Newton meter square, another unit of permittivity. We can also say that it is ability to store electrical potential energy when an electric field is applied. Another way of, means one more way of defining is ability to store electrical potential energy when an electric field is applied, that also will be expressed in terms of permittivity. The symbol of permittivity is epsilon. For free space or air, epsilon naught. For a medium, it is epsilon. For free space or air, epsilon naught. For a medium, epsilon. Now, I will take the ratio. I will take the ratio between these two. What and what? Epsilon naught and epsilon. What is epsilon naught? Permittivity of free space. And what is epsilon? Permittivity of a medium. This ratio is called as epsilon r. What it is epsilon r? It is called as relative permittivity. What we say? Relative permittivity, or it is also called as dielectric constant. Relative permittivity or dielectric constant. Right. The unit of permittivity is Farad per meter or Coulomb square per Newton meter square. What about the unit of epsilon r? What about the unit of epsilon r? It is a ratio. So, does a ratio have any unit? Does a ratio has any units? Ratio ki units untava? Undavu. Because it is a ratio between two permittivities. So, there are no units, means unitless quantities. A physical quantity which does not have any units, unitless physical quantity. Okay. It is relative permittivity or dielectric constant, no units. This permittivity value is very high, some value, that value is high. So, what I can say about the material? Such materials polarize easily, such materials polarize easily, and they are very good electrical insulators. Polarization will be easy and they are very good electrical insulators. Which one? Whose permittivity, relative permittivity value is high, very good insulators, electrical insulators. They can be polarized easily. What is the meaning of polarized? Formation of poles. When the poles are going to form? When external field is going to be applied. Okay, na? And does it have any units? No units. Okay, named as epsilon. What we say? Epsilon. Next, we are going to say polarization. Electric polarization. Electric polarization. Already you know what is the meaning of polarization, just now we discussed. Formation of poles. Where? Inside the atom. When? So, that is nothing but called as electric polarization. Okay? Right. Now, this polarization depends on what? Applied electric field. So, P is directly proportional to E. Right or not? Polarization is directly proportional to E. Because of E we can see P. Where we see such bodies are dielectrics. If not there, not possible, insulators. Now, what I do? In the place of proportion, I will write is equal to a dash into E. So, what I am going to fill with this dash? Dash we write as alpha. Generally, what is the name given to its alpha? Proportionality constant. Generally, we call as proportionality constant. This proportionality constant is called as polarizability. What we say? Polarizability, indicated with letter alpha. So, from this, what is alpha? P by E. So, what is polarizability? The ratio between polarization electric field. That ratio is called as polarizability. Okay. Right. Now, What is mu? Dipole moment, directly proportional to E. So, from this mu is equal to what? Mu is equal to E into dr. Something I am missing. Mu is directly proportional to E, mu is equal to alpha E. Yes. Mm, okay. Mu is equal to alpha E, dipole moment, polarization. Okay, same meaning will come. No issue. Next, polarization vector. Polarization vector P. What? What is that polarization vector P? See, we have got polarization in the substance. If you take unit volume of the substance, if you take unit volume of the substance, how much polarization is going to be present? Sorry, how much dipole moment is going to be present? Sorry, in the unit volume of the substance, how much dipole moment you are going to see? That will be expressed in terms of polarization vector P. So, what I can say? Dipole moment for unit volume. Dipole moment for unit volume is called as polarization vector P. For only one dipole will be there, many number of dipoles will be there. Okay. So, P is equal to n into mu bar, where n is the number of atoms or molecules and mu bar is the average dipole moment. What is mu bar? Average dipole moment per molecule. Okay. So, but what is mu? Mu is equal to what we know? Mu is equal to what we know? Alpha e. Therefore, P is equal to what I can write now? N into mu. Mu is nothing but what? N alpha e. N is the number of molecules, alpha is the polarizability, A is the electric field strength. In free space, this equation can be written as N alpha epsilon naught E. N alpha epsilon naught E. Number of molecules, polarizability, permittivity of free space, E bar is field strength. Okay. So, what is polarization vector? Dipole, or it is also called polarization density. Polarization density. Density means what? Density, what is the meaning of density? Mass by volume. So, volume, unit volume, how much polarization is there, that will be expressed in terms of polarization vector. Expression P is equal to N alpha epsilon naught E. What is N stands for? Number of molecules, alpha polarizability, epsilon naught permittivity of free space, E is the electric field. Okay. Next, one more term that you have to see in this unit is electric susceptibility. Electric susceptibility, the symbol is how to pronounce it? KIET, Saya. So, that is symbol of electric susceptibility, it is psi. Okay. If you say psi, I will say psi. Okay. So, what is this psi? In terms of, actually our discussion is about what? Polarization. Yes or no? When the polarization is going to take place? When electric field is going to apply. So, what is chi now? What is psi? It is a ratio between, it is a ratio between P and E. I can write or not? Ratio between P and E is psi, called as electric susceptibility. Means what actually? See, to polarize a body, we pass current. Only one type of body is there? More than one type body will be there or not? So, polarization takes in all bodies the same extent. In some cases it may be easy, in some cases it might be hard. Some bodies can be easily polarized, some bodies may not be easily polarized. Antena? All bodies will polarize easily? Means how easily we can polarize that information we get from chi, called as electric susceptibility. How easily we can polarize a body, that information we get from electric susceptibility. In magnetism also, their magnetic susceptibility we used to say it, same thing will be repeated. Okay. What we can say, how easily we can polarize the body, and if you want to polarize the body, what we have to do? We have to pass, we have to apply electric field. Yes or no? In the presence of electric field only polarization is going to take place or not. And next after this, electric displacement vector. Electric displacement vector indicated with the letter D, where D is given as epsilon naught E plus P. What is D? Epsilon naught E plus P. Then what is electric displacement vector? Just one statement you write. It is a vector quantity. It is a, write the statement. It is a vector quantity representing the total electric flux density. It is a vector quantity representing the total electric flux density representing the total electric flux density, accounting for both free charges and material polarization. Free charges and material polarization. Accounting for both free charges, material polarization is nothing but what? Electric dielectric displacement vector, which is given by D is equal to epsilon naught E plus P. Now, we have to see the derivation part for this. So, to derive this, we make use of Gauss law. We make use of Gauss law concept, and we are going to derive. What is Gauss law? Integral E dot ds is equal to 1 by epsilon naught into q, closed integral, closed surface integration E dot ds is equal to 1 by epsilon naught into q. This is Gauss law. By using this Gauss law, we are going to derive the relation. For that purpose, first we take a parallel plate. Okay, we take parallel plates, two ends connected to the electric field. So, what charge is going to develop on one plate? Positive charge, another plate negative charge. Okay, na? Right. So, between this, because of these charges, a field is going to set up from positive to negative. That field I will write as E naught. That field I write as E naught. Now, from Gauss law, I can write the charge that is q dash q or q, one positive, the other one is negative. So, apply Gauss law, what will come? E into integral ds is equal to 1 by epsilon naught into q, E into this is nothing but A will be equal to 1 by epsilon naught into q. From this E is equal to 1 by epsilon naught A into q. This is equation 1. That is equation unda testava బయటనే ఉందా just 1 minute. రేగా Hello? Only titles. What and what we discussed. Don't see man. ఒక్కటి చూసావా? చూసి రాసినాక అందరు రాస్తారు చూసి. కొంచెం ఆలోచించి ఏమైనా టైటిల్స్ డిస్కస్ చేసాం. ఓన్లీ టైటిల్స్ ఐమ్ ఆస్కింగ్. Don't copy a hero. Whether he wrote right or wrong, బ్యాక్ సైడ్ రాయమని చెప్పాను. టైటిల్సే, హెడ్డింగ్స్. టైటిల్స్ అంటే ఏంటి? హెడ్డింగ్స్. రాయ్. అర్థం కాలే. ఇప్పుడు రాయి ఇక. ఇప్పుడు రాయి, నేను చెప్పానుగా. రాయ్. వెట్. ఓన్లీ టైటిల్స్ రాశారా? ఓవర్. అయిపోయిందమ్మా. బాయ్స్. ఓకే. beside write the formula. Formulas, only formulas. Don't say, only formulas you write. Formulas రాయండమ్మా. Write the formula. Write the formula. Don't copy please. అమ్మా ఆలోచించి రాయి. రైట్ ఆర్ రాంగ్ సెకండరీ. ఫస్ట్ యూ రైట్, మేక్ హ్యాబిట్. చూడు ఎంత కష్టంగా ఉందో రాయడం. బుక్ నీదేనా వేరే వాళ్ళదా? ఎవరిదా బుక్? రఫా? ఏంది? డిక్టేషనా? పాతదా? 24, 25, 24, 25లో డిక్టేషన్ ఉంటుందా? ఫార్ములాస్. Formulas only you write. Don't see clauses. కాకపోవచ్చు, అవసరమా? ఫార్ములాస్ ఎన్ని గుర్తుంటే అని రాయండి అమ్మా. ఓవర్. బిసైడ్ ద టైటిల్ ఆర్ అవే ఫ్రమ్ ద టైటిల్, సపరేట్ ఆల్సో. అన్ని టైటిల్స్కి ఫార్ములాస్ ఉండాలని రూల్ లేదు కదా. ఓవర్. రిటర్న్. ఓవర్. కంప్లీటెడ్. సో హెడ్డింగ్స్, హౌ మెనీ హెడ్డింగ్స్ యూ గాట్ మ్యాక్సిమం? 10, 9, 8? 8 headings. 9. How many students wrote 9 headings? Raise your hands. Stand please. 9 headings. Who wrote 9? Nobody? 8? Stand. అమ్మా నిలబడండి అమ్మా. యు ఆర్ నాట్ డూయింగ్ ఎనీ క్రైమ్. 9. 8? 8. గుడ్. 8 headings. 7? Stand. అమ్మ కూర్చో. 7 headings. Own headings copied. 3 are standing. Own or copied? Tell me 3. What is the first heading you wrote? Read. See and read. First heading. Sir, middle one. What is your first heading? Yours? Amma, please. Girls. This one, what is saying? Gatiga. Permittivity. First title. Second title? Say and say. Second, you. Polarization. See and read. Okay, good. Total how many? 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. 6. 6 titles. 6 titles. Nobody? Read last one. You only. Specs boy. Last sixth one you read. Yourself. Your sixth one. Choose చెప్పు. Electric susceptibility. Yours. Parametric. First one. Capacitor. రెండు సేమ్ ఉన్నాయి ఇద్దరివి. ఫస్ట్ సేమ్, లాస్ట్ సేమ్. థర్డ్ వన్ ఏంటమ్మనేది? వాట్ ఇస్ యువర్ థర్డ్ టైటిల్? యువర్స్. ఫస్ట్ సేమ్, లాస్ట్ సేమ్, థర్డ్ సేమ్, 3 ఆప్షన్స్ సేమ్ అన్నప్పుడు ఏమనాలి? కాపీడా? సెకండ్ వన్? గుడ్. బట్ గుడ్. Total how many? 5 or 6? 6. 5? 5 titles. No one? 4? 3? 2? 1. 8 stand? 8 or 9 stand? 7 stand? 6 stand? When I called, why you not stood? First I called you are 6. At that time, why you not stood? Emma, please. I called you. At that time, why you not stood? 5, 4, 4. How many? Sure. Count. Once count. 4 or 5? Kavya sava. Yours. Place. Sure. Yours. When I called 5, at that time you stood? No. ఏమ్మా ఎన్నమ్మా ఎక్కడ? అప్పుడు ఎన్ని నీ కౌంట్ ఎంత అక్కడ? మరి నిలబడ్డావు అప్పుడు? వై? సార్ హౌ మెనీ? వెన్ ఐ కాల్డ్ 7, ఎట్ దట్ టైమ్ యూ స్టూడ్? గుడ్. అప్పుడు నిలబడ్డావా? అప్పుడు నిలబడ్డావా 7 అన్నప్పుడు? ముగ్గురు నిలబడ్డారా? 6 అప్పుడు నిలబడ్డావా? సార్ సార్ చూసి రాస్తున్నావా? హౌ మెనీ? నీకు 5 అని పిలిచినప్పుడు నిలబడ్డావా? నిలబడ్డావా? ఎందుకు? Now all are standing. Your number is 8? Okay, done. Sit all of you. So finally you wrote the titles. Actually, why I want to say this, because many students, they won't read question, but they read answer. When the teacher asks to say about question, they will think what to say. Yes, I notice many students, they won't read question, but they will say answer. What is the question? Question for that answer means he will think what. Habituated. Formulas రాశారు కదా? How many formulas maximum? 5? 7 formulas stand. ఇప్పుడు చూస్తే ఇప్పుడు 7 stand. 6 formulas. 6 formulas stand properly. ఇప్పుడు బయటకు వస్తారు కానీ 5. I'll check. 5. What is the 5th formula? Read. నువ్వు రాసినది ఫార్ములా. ఓకే. 5, 4, 3, 2, 1. Right. Standing, sit, sitting, stand now. Standing, sit, sitting, stand. Now what is the answer that you are giving? ఇంతమంది నిలబడమంటే అందరు నిలబడ్డారు కదా, ఇప్పుడు ఏమైంది మరి? రాయడం అంత కష్టమా అమ్మా? ఎన్ని రాసావు? నేను 4 అన్నా ఎప్పుడు నిలబడ్డావా? వై ప్లీజ్ when you are writing exam every title there is an answer ఉంటుందా? ప్రతి టైటిల్కి ఒక ఆన్సర్ ఉంటుందా? సో ఇఫ్ యూ రైట్ దట్ ఆన్సర్ అండ్ ఇఫ్ యూ డూ ద రిమైనింగ్ వర్క్ minimum mark will be given 1 mark. Listen all of you, why I am saying this, because every title ki there is a one mathematical equation directly or indirectly unnaya. Dipole moment, polarization, తర్వాత dipole polarization vector, displacement vector, every title ki equation ఉందనుకోండి. In exam if you write that equation 1 mark will be given. If you don't know the derivation part secondary, but try to write the final answer, one line answer, you have to attend it. So question answer means you are attending that answer, 1 mark will be given at any cost. Understood what I am saying? జనరల్గా ఏంటి, టైటిల్ చూడగానే మాకు రాదు, ఐ డోంట్ నో అన్న ఫీలింగ్ తోటి we used to skip the questions. పాసిబిలిటీ ఉందా? బట్ యూ డోంట్ నో ద ఫైనల్, యూ నో ద ఫైనల్ ఆన్సర్. రాస్తారా? వెరీ ఫ్యూ పీపుల్ విల్ రైట్ దట్ ఆన్సర్. వెరీ ఫ్యూ పీపుల్ విల్ రైట్ ద ఆన్సర్. మెనీ స్టూడెంట్స్ ఆర్ గోయింగ్ టు స్కిప్ ఇట్. సో టు నవ్ ఆన్వర్డ్స్ యూ స్కిప్. ఏం చేస్తారు? క్వశ్చన్ నెంబర్ వేసి try to write the one line mathematical equation, surely 1 mark will be given. అర్థమైందా what I want to say, my intention? Please sit all of you. Right. So 2 plates connected to electric field. When you are going to give, one plate develops positive charge, another plate negative charge. Electric field is going to set up from positive to negative. From Gauss law, electric field E is equal to what I can write now? Q by epsilon naught A. Now what I do? The plate, I am introducing one dielectric material. So positive, negative, the charge is Q. Right. When a dielectric material is introduced, because of the field, dipoles are going to create. Those dipoles you can call as induced dipoles. What we say? So here positive means negative, here negative means positive, means polarization is going to take place inside the substance. Now this electric field we called as E naught, and this electric field is going to develop, we call as EP, because of polarization, because of poles. And see the direction of E naught and EP, same opposite. So resultant field is going to increase or decrease. So resultant electric field, what I can say, is E naught minus EP. And next, the charges that are going to be induced, Q prime, where? On the dielectric material. When it is introduced between the plates. So what is the net charge that you are going to see? Q minus Q prime. What is the net charge that you are going to see? Q minus Q prime is the net charge that you are going to see. Now apply Gauss law. From Gauss law, integral E dot ds is equal to 1 by epsilon naught into q, general formula. Right. After introducing dielectric material, what is the charge that is going to be left? Q. How much it is? So, in the place of q, what I write? Q minus q dash, q prime. So, what I will write? Okay, na? So, charges means what I can say, the charge present on the plate and induced charge will not be is same, different. Now, simplify this. E integral ds is equal to 1 by epsilon naught q prime q minus q prime or q dash. Further, E dot A is equal to 1 by epsilon naught q minus q prime. From this E is equal to what? 1 by epsilon naught A into q minus q prime. Okay, right. Simplify this. E is equal to q by epsilon naught A minus q prime by epsilon naught A. Bring that q prime this side. Q prime by epsilon naught A is equal to E minus something is wrong. Q minus q prime by epsilon naught, rearranging q by epsilon E plus. So, what will come, tell me? E plus q prime by epsilon naught A. I can write a, this term I took this side. So, q by epsilon naught is equal to minus will become plus A plus q prime by epsilon naught A. Okay, right. Here q prime by A I call as P. Q prime by A I will take as P. What is P? Polarization vector. What is polarization vector? Dipole moment for unit volume. Here A area of cross section is there. Right. What I do? Q prime I will take by A into D I will make it. Multiply and divide with the D. Any change? That equation is going to be changed. Any changes? Both the equations are same or different? Same. What is Q? Q prime? Charge, induced charge. What is D? Distance between them. So, product of induced charge and distance is nothing but what? Mu. And what is A? Area of cross section. Area of cross section nothing but length into breadth. D is nothing but height. Then what I am going to get? So, which is equal to P. Got it? So, dipole moment for unit volume is polarization. Nothing but in terms of area of cross section, what I can write? Q dash by A, I can write or not? Means where Q dash by A, there I can substitute P. So, what will come now, tell me? Therefore, Q by epsilon naught A will be equal to what? E plus P by, I can write Q dash by A, what I took? P. Right. Now, simplify this further. Q by A, bring this epsilon naught this side, epsilon naught E plus epsilon naught P by epsilon naught. So, from this Q by A, which is equal to what? Epsilon naught E plus P, which is equal to D. See the title, displacement vector D is equal to what we wrote? Epsilon naught E plus P. So, epsilon naught E plus P is equal to I'll write neatly. Epsilon naught E so d is equal to epsilon naught E plus P. This is what? Displacement vector D, derivation part. So how we got this? Tell me. First, what we took? Parallel plates. Then what we applied? Gauss law. Then we got expression for this E. E is equal to what we got? Epsilon naught, sorry, Q by epsilon naught A. Next, what we done? We introduced what? Dielectric material. So, what is going to produce induced charges, induced dipole moment, and the direction is opposite, means polarization we can see it. With respect to this charge E naught, with respect to induced charge AP, direction of A naught and AP is opposite. So, resultant value is going to decrease, nothing but it allows, it does not allows. It is not going to allow insulators. In same direction means conductors, right. So, net EMF is, net field is E naught minus EP, and the net charge that you are going to see is Q minus Q dash or Q prime. Now, for this net charge, you apply Gauss law. Integral E dot ds is equal to 1 by epsilon naught Q minus Q prime. Means in the place of Q, what I took? In the place of Q, what I took? Q minus Q prime. So, therefore, E line integral closed surface ds is equal to 1 by epsilon naught. Simplifying, so what I got finally? E is equal to 1 by epsilon naught A into Q minus, multiply this, then this equation is coming. Next, here what we do? We apply this concept Q prime by A, we name it as P. Why? Because I am multiplying Q prime D on both, multiplying and dividing with D, then Q prime is charge into D separation, nothing but dipole moment. Area multiplied with one more dimension, then you will get volume. So, dipole moment for unit volume is polarization. So, where Q prime by A is there, I am writing P. So, here Q prime by A is there or not. So, Q epsilon naught A is equal to E plus P by epsilon naught. Then multiply this epsilon and simplify, you will get epsilon naught E plus P. This epsilon naught E plus P we take as D, displacement vector. Okay. So, this is electric displacement vector. Next, relation between epsilon r and chi. This is okay now? Where? Right first. Next topic is relation between epsilon r and chi. That is, relation is epsilon r is equal to 1 plus chi. Here electricity psi E also we can write with respect to electric field, that is, because the same symbol is used in magnetism also. Their magnetic susceptibility we used to say. Here electric susceptibility. E means electric susceptibility. Over? Right. To derive this, we make use of the previous derivation. We know displacement vector D is equal to what? epsilon naught E plus D is equal to epsilon naught E plus P. What is P? Expression for P. That's just about the P is equal to epsilon naught psi E. P is equal to. So D is equal to what? Epsilon naught E plus P. Epsilon naught psi E into E. Psi means it is not x. Don't think that it is x. So D is equal to epsilon naught E. So what I can take a common now? Epsilon naught E. If I take outside, what will come? Okay. Further, bring this side. D by E is what? D by E is equal to what I can write now? Epsilon naught into 1 plus, right. Already this also we same. We know D is equal to epsilon E. From this epsilon is equal to permittivity. So here what I can write now? Epsilon is equal to epsilon naught plus epsilon is equal to epsilon naught into 1 plus chi. Right. We know. What is epsilon r? Epsilon by epsilon naught. From this epsilon is equal to epsilon r epsilon naught. So therefore, what I can write now? In the place of epsilon r epsilon naught is equal to epsilon naught plus 1 plus chi. Cancel epsilon naught both sides. Epsilon r is equal to what? 1 plus chi. This is a relation between dielectric constant and electric susceptibility. Over. So previous equation is what? Displacement vector D. Right. Completed. See. Over. Stand once. Read the line that you are writing. Phone, phone, phone. Show me your copy. Read. You read what you wrote. చదువు గట్టిగా లౌడర్ ఉందా అక్కడ ఉన్నది చదువు అని చెప్పాను వాట్ యూ రోట్ యూ రీడ్ జస్ట్ యూ రీడ్ వన్స్ జస్ట్ రీడ్ వాట్ యూ రోట్ ఫస్ట్ అన్వర్డ్స్ గట్టిగా
ఎలక్ట్రానిక్స్ ఇన్సులేటర్స్ పర్మిటివిటీ
read listen what is writing
ఎలక్ట్రానిక్స్ ఇన్సులేటర్స్
dielectronics dielectronics
డైఎలక్ట్రానిక్స్ ఇన్సులేటర్స్ పర్మిటివిటీ పోలరైజేషన్ ఎలక్ట్రిక్ పోలరైజేషన్ వెక్టర్ సస్పెక్టబిలిటీ
then
డైపోల్ ఎలక్ట్రిక్ డిస్ప్లేస్మెంట్
then
ది ఎలక్ట్రిక్
this is the thing that you are doing busy with the phone yes or no don't lie for what purpose you are not even writing the equations final equations also what's the name Ganesh Tanish can you feel shame no లేదా లేదట చాటింగా మరి ఎంత బిజీ ఉన్నావు ఫోన్ తోటి ఈవెన్ యూ ఆర్ నాట్ రైటింగ్ వాట్ ఐమ్ రైటింగ్ ఆన్ ద బోర్డ్ headings and titles also you are not writing then what you will write in the exam can you say the equation for D relation between epsilon r and chi busy in chatting with whom I don't know busy in chatting with whom someone is there out send message reply that I struck I caught huh? Because you are not writing what I am writing on the board Tanishk only Tanishk famous name where I heard ఏదో టీవీలో వస్తుంది ప్రోగ్రామ్ అది కార్టూన్ ఛానల్ ఎస్ డోరమేనా కార్టూన్ ఛానలేనా అందుకోసం అన్నావు సెట్ సిట్ సార్ డూ యువర్ వర్క్ say previous derivation is d is equal to epsilon naught t plus p and this derivation is epsilon r is equal to 1 plus chi. These two equations you try to remember for solving problems also. Okay. Next, we are going to see the types of polarizabilities. Types of alpha. Next, we are going to see types of alpha. Tanishk, what is alpha? What is alpha? Any name is given for alpha? No name according to him. So, I will call Tanishk only now. Shall I? Accepting, huh? No, yes, no. What is alpha? Polarizability. Okay. There are three types of polarizabilities. How many types? Ionic, electronic, orientation. Ionic posability, alpha I, electronic posability, alpha E, orientation posability, alpha O. Ionic posability from ionic polarization. Orientation posability from electronic polarization, electron posability. Orientation posability from orientation polarization. Okay. Where is this ionic posability in ionic substance? Ionic posability we are going to say in ionic substance. Orientation where dipoles are going to form. Electronic posability in all substance I can say it. What is ionic substance? What is ionic substance? What is ionic substance? Example for ionic substance? Have you heard about this in chemistry? Sodium chloride is an example for, it is what in general terminology? Salt. Which salt? Means which is there on the table. Table salt means table salt అంటే ఏంటి? టేబుల్ మీద ఉండే సాల్టా? మరి తెలియదా? వేర్ ఇట్ ఈస్ యూస్డ్? అమ్మా ఎక్కడ యూజ్ చేస్తాం? NaCl. వన్ ఆన్సర్ ప్లీజ్. ఎక్కడ యూజ్ చేస్తాం? తెలియదా? మన భాషలో ఏమంటారు దాన్ని? వాడుక భాష. ఉప్పు. బా థ్యాంక్ గాడ్. Uppu, salt. Salt is what? Uppu. Great. So finally it is the formula for salt is, it is an example for ionic substance. Why? Because in ionic substance which bond is present? Ionic bond. How ionic bond is formed? Cheppandi. LCM. How ionic bond is formed? How ionic bond is formed? Bond you know? Where? Where we see bond? One answer please. ఎక్కడ బాండ్ ఉంటుంది? జేమ్స్ బాండా? మరి ఏం బాండ్? ఎస్, equivalent bond. What is bond? Where? Sharing of where? Between, in atom, between atoms. That bond is a bond name anale. Sharing of electrons between two atoms is covalent bond. But this bond is, how it is formed? Again sharing means covalent, you only said. Again ionic also sharing a. Yes. Someone, one voice I came, I heard. By losing of electrons or gaining of electrons. Lose electron, where it will go? Vanish. Atom is losing electron. Where it will go? To another atom. So generally what we say, one atom is giving, another atom is taking. Transfer, you can say a transfer of electron between two atoms. Which bond? Ionic bond. Transfer of electron between two atoms, ionic bond. Where ionic bond is there, such substance? Ionic substance. So one atom is losing electron, another atom is gaining electron. Yes or no? So what they are going to form? One atom is losing electron. Loosed electron is taken by another atom. So what it is going to form? They changes into atoms are losing and gaining electrons. So atom changes into atoms combines to form molecules, but atom is losing electron, another atom is gaining electron. So that atoms చెప్పండి అయాన్స్ ఎవరు చెప్పారు అది గుడ్ నైస్ గుడ్ పక్కల చేయలు ఆడటం మరి నీ చేయపులు ఆడతాం వద్దా వద్దా రైట్ atoms are losing and atoms are gaining, so that atoms are changing into ions. So one atom is losing, what charge it is going to develop? Another atom is gaining electron. So positively charged atoms called ions, what is the name given to them? Cations. Other atom is gaining electron, negative charge, anions. So where we find these cations and anions? Where ionic bond is present, ante kada, cations and anions. What about the size of cation and anion? Actually transfer of electron takes place between metal and non-metal, antena. Sodium is a metal, chlorine is a non-metal. Sodium is losing electron Na plus, chlorine is gaining electron Cl minus. So metals and non-metals, between metal and non-metal we can see the transfer of electron. Metal electropositive, non-metal electronegative. Anions and cations are going to form or not. So masses of anion and cation will be same or different. One mass will be small, the other mass will be big. So from that we get expression for alpha I, which is equal to E square by omega naught square into 1 by small m plus 1 by capital M. The ionic possibility is alpha I, which is given by E square by omega naught square into 1 by small m plus 1 by capital M. So where this polarizability we are going to see in ionic substance, where this is going to be absent in covalent substance. And in this equation any temperature is there, so it is dependent of temperature, independent of temperature, it is independent of temperature. Okay, so we can derive this. How to derive this? We know dipole moment mu, actually mu is equal to what? E into d. In this case d we take as x1 plus x2. Mu is equal to what? E into x1 plus x2. So what is x1 x2? Displacements of ions. When the ions are going to displace, when external electric field is going to apply, dipole moment will be there. Means we have to find x1 value as well as x2 value. Okay, for that purpose we make use of restoring force. Restoring force E is equal to m omega naught square and F is equal to E. Okay, another formula is F is equal to x1 k1. From this we get this equation where k is equal to, sorry, k is equal to omega square, x2 k2. From this x1 is what? F by k1, x2 is F by k2, x1 is expression for force in terms of electric field, E, k restoring force constant, m omega naught square for one ion, x2 is equal to E by capital M omega naught square, one for cation, one for anion. So you got x1 value, you got x2 value, where you substitute in equation 1, then you will get mu, then you simplify, then finally you are going to get this equation. Okay na? So I am saying only qualitative part. So ionic possibility alpha I, which is equal to E square by omega naught square into 1 by small m plus 1 by capital M. This is present in ionic substance and not possible in covalent substance. Here there is no temperature, so it is independent of temperature. Ionic substance means ionic bond, covalent substance means covalent bond. Ionic bond is formed by transfer of electron, covalent bond is formed by sharing of electron. The second possibility is alpha E, which is given by 4 pi epsilon naught r cube. What is second possibility? Alpha E, whose equation is 4 pi epsilon naught r cube. Alpha is called as electronic possibility. What we say? Electronic possibility. In all substance we can see this, because substance made up of atoms, atoms contains electrons and nucleus. Before, center of electron nucleus will be same. After applying field, electrons and nucleus are going to be displaced. When electrons and nucleus is displaced, dipole moment will be there, same process. Okay. And finally we are going to get this equation, and in this equation 4 pi epsilon constant, what I can write now? Alpha is directly proportional to r cube, where r is the radius. R is the radius. So, this is what ionic possibility, electronic possibility. Next, the third possibility is what? Orientation possibility. Electronic polarizability, orientation possibility. What is the meaning of orientation? What is the meaning of orientation? Expression is mu square by 3 kb into T. Orientation possibility alpha is equal to what I can write now? Mu square by 3 kb into T. So, what is orientation possibility? And where we find this? In polar molecules. Where we find this? In polar molecules. Polar molecules means dipoles will be there or not? Dipoles will be there. Polar, polarity, poles. Poles means positive negative charge. Dipoles. Okay. So, in polar molecules, this orientation possibility is going to be present, where dipoles are going to present, and these dipoles are going to present in these molecules even in the absence of external field. Dipoles will be present even in the absence of external field, but their orientation is random. What is the meaning of random? Random orientation means random regular. If I represent dipoles in the form of arrow mark, so nearly 5 dipoles are there. How they are oriented? That is orientation. In the when it is exposed to external field, any difference you are going to notice? So, first one is random orientation, the second one is regular orientation. So, dipoles which are oriented in different direction, when they are exposed to external field, random changes it to regular orientation. So, where these dipoles, there only we can see this posability, and expression for orientation posability is alpha which is equal to mu square by 3 kb into T. What is mu? Dipole moment. Kb, Boltzmann constant. And what is T? Temperature. Means what I can say? It is dependent of temperature, independent of temperature. It is temperature dependent. Previous two cases, any temperature what is there in the equation? So, those two are independent of temperature, but this is dependent of temperature. And in what way it is? Directly relation, inversely related. It is inversely related. As the temperature increases, orientation possibility decreases and vice versa. Okay. Next. Okay. So, how many types of possibilities is in? Three types. What and what? Ionic possibility, electronic possibility, orientation possibility. This all is nothing but called as space charge possibility by summing them, which is equal to alpha I. What is alpha I? E square by omega naught square into 1 by small m plus 1 by capital M plus alpha E 4 pi epsilon naught r cube plus alpha O mu square by 3 kb into T. Space charge polarization or space charge polarizability. By adding these three, we are going to get space charge polarization or space charge polarizability. Okay. Actually, space charge polarization means what I can write now? P is equal to ఇదే కదా. So in the place of alpha polarization, if you want to write, in the place of alpha you have to write all these things. Then you will get a space charge polarization. This is space charge polarizability. Okay, na? Means the sum of electronic, ionic and orientation possibilities, you will get space charge polarizability. Next, important Clausius Mosetti relation. The next topic that we are going to see is Clausius Mosetti relation. What is Clausius Mosetti relation? Epsilon r minus 1 by epsilon r plus 2 is equal to n alpha e by 3 epsilon naught. This is Clausius Mosetti relation. What it is? Epsilon r minus 1 by epsilon r plus 2 is equal to n alpha e by 3 epsilon naught. This equation is called what? Clausius Mosetti relation. Please read. You only read the equation, title and equation. Clausius Mosetti relation. What it is? Epsilon r by is equal to n e epsilon naught. Epsilon naught. అరవస్తుందా నీకు? అరవస్తుందా? అరవడం వచ్చా? నాలుగు తిరగట్లేదు మరి. అర్థం కాలే. కొంచెం ఫస్ట్ ఇప్పుడు ట్రై. ఇప్పుడు ఒకసారి చదివావు కదా, మళ్ళీ ఒకసారి చదివి. రీడ్ వితౌట్ గ్యాప్. ఎన్ మైనసా? ఇంటికి వెళ్ళి బుక్ బట్టి గట్టిగా చదవడం నేర్చుకో. టంగ్ తిరగట్లేదు. ఓకే, రైట్. సో టెల్ మీ వాట్ ఈస్ ఎప్సిలాన్ ఆర్, ఆల్ఫా ఈ and epsilon naught. What are these three? Relative permittivity, electronic polarizability. This is what? Orientation. Orientation. Permittivity of. So question may be direct. Derive Clausius Mosetti relation, direct question. Second possibility is write the relation between epsilon r alpha e epsilon naught. Write the relation between epsilon r alpha e epsilon naught అట్లా అడగచ్చు. ఇంకొకటి ఏంటి, వన్ మోర్ వే ఆఫ్ ఆస్కింగ్, రైట్ ద రిలేషన్ బిట్వీన్ relative permittivity, permittivity of free space and electronic polarizability. The way of asking three ways ఉంటుంది. క్లాసెస్ స్మాల్ సెట్ అని ఇవ్వచ్చు అంతే. డిరైవ్ క్లాసెస్ స్మాల్ సెట్ రిలేషన్ అంటే ఇది రాసి యూ హెవ్ టు డిరైవ్ ఇట్. సెకండ్ పాసిబిలిటీ ఏంటి, రైట్ ద రిలేషన్ బిట్వీన్ ఎప్సిలాన్ ఆర్ ఆల్ఫా ఈ ఎప్సిలాన్ నాట్ అంటే యూ హెవ్ టు రైట్ దిస్ రిలేషన్, యూ హెవ్ టు డిరైవ్ ఇట్. థర్డ్ కేస్ ఏంటి, వాట్ ఈస్ ద రిలేషన్ బిట్వీన్ డైఎలక్ట్రిక్ కాన్స్టెంట్, electronic possibility and permittivity of free space. Means you have to write this and you have to derive this. So three ways of asking question. Direct is the no issue, but write the relation between dielectric constant, permittivity of free space అంటే మైండ్లో క్వశ్చన్స్ వచ్చినాయి అనుకోండి కన్ఫ్యూజ్ కదా, you have to write this equation and you have to derive it. Okay na? Right. So to derive this relation, to derive this relation, we take a solid derivation, proof, okay, derivation. Let us take a solid dielectric material, free from ions and free from dipoles, free from ions and free from dipoles. Before that, in this derivation, we make use of one formula proposed by Lorentz. Lorentz proposed one expression for internal field EI, which is given by E plus P by 3 epsilon naught. This is a formula, Lorentz expression for internal field. EI is equal to, sir, ఏం చేస్తున్నావు, ఎందుకు వస్తుంది, దానికి భయం లేదా, నీ చేయి భయం లేదా, దాన్ని ముడితేనే కదా బయటకు వచ్చేది. రోజు తగులుతుందా, ఇప్పుడే తగులుతుందా, అది అలవాటు కదా, ఎప్పటి నుంచి చేసుకుంటున్నావు కదా, ఇప్పుడు కొత్త కాదు కదా. అయిపోయిందా తగలడం, అయిపోయిందా, సరే నేనేం చెప్తున్నా ఇప్పుడు, మరి ఏం చెప్తున్నా, బోర్డులో ఎక్కడ రాస్తున్నా, ఏది చదువు, దాన్ని ఏమంటాం, what is the, who gave that, Lorentz expression for internal field in a solid. That after this derivation I will say how that equation came, ఎట్లా వచ్చింది అనేది ఈ డెరివేషన్ తర్వాత చూద్దాం. ఓకే రైట్, బట్ ఇన్ దిస్ డెరివేషన్ we use this formula, keep in mind. Okay na? Right, coming to this derivation, we take the substance free from ions and free from dipoles, free from ions and free from dipoles. Free from ions ante no ionization, no dipoles, means ionic possibility will be how much untunda, no ions, so ionic possibility will be there, zero. No dipoles, orientation possibility is zero. Then what is present, only electronic possibility is going to present. Okay na, only electronic possibility is going to present. Right, so when you apply electric field, polarization will be there. So what is polarization vector P, n alpha into E. Yes sir, expression for polarization vector is n alpha E into E. Here alpha is equal to alpha E I take. Why? Because first only we assume that no ions, no dipoles, only one electronic possibility. Next here E we call as internal field. E is equal to what, EI, where EI is equal to what, E plus P by 3 epsilon naught. So, substitute here P is equal to n alpha into E I. In the place of E is equal to E I, where V I is equal to what? E plus P by 3 epsilon naught. Okay, na? General formula for polarization, alpha is equal to alpha E is equal to E I. Why we take alpha is equal to alpha E? Because alpha I, alpha O are 0. So, electron opposability is electron opposability, that is why alpha I. And other condition is what? According to Lorentz field, E is equal to E I, which is equal to A plus P by 3 epsilon, that I substituted. Right. Now, simplify this. Okay. Multiply this. P is equal to n alpha E plus n alpha E P by 3 epsilon naught. Okay, na? P is equal to n alpha E plus n alpha E P by 3 epsilon naught. Simply I multiplied. Okay, na? Simplify this. Bring P one side. P minus n alpha E P by 3 epsilon naught is equal to n alpha E into E. Now, what is common? P. So, what will come? N alpha E by 3 epsilon naught is equal to n alpha I. So, from this P is equal to what? N alpha E by 1 minus n alpha E by 3 epsilon naught. This is equation 1. Writing a? Rastunnara? Shall I change the screen? ఏముంది పైన? ఫస్ట్ అయిపోయిందమ్మా? Shall I change the screen? Shall I drag up? Boys, back side. Completed? Sure. Where did you write? Fast no. ఇంకా అయిపోలే డెరివేషన్, 2 గీతలు గీసేసా. అలవాటు కదా. డెరివేషన్ లాస్ట్ ఏం రావాలి ఆన్సర్ మనకి? ఆన్సర్ ఏంటి దీనికి? ఒకసారి చెప్పు సార్, ఆన్సర్ ఏంటి చదువు. ఏ మనం ఫైనల్ ఎక్కడ కంక్లూడ్ కావాలి? గట్టి స్టాండ్, స్టాండ్ ఫస్ట్. రైట్. చదువు, దానికి బాక్స్ వే, డ్రా వన్ బాక్స్, అది ఆన్సర్ అన్నట్టు. గుడ్. అయిపోయిందా సార్? డెరివేషన్ అయిపోయిందా? ఎక్కడికి రావాలి? ఈఆర్ అంటే ఏంటి? Got the relation? Right. Okay. So, three ways this question can be asked. You can complete it. Now, tell me what we used in this equation. To derive this equation, we depend on one equation proposed by Lorentz. What is that? Lorentz expression for internal field. Just I will give idea about that. E actually see this is a material. When you keep an external field E, when you apply, what must develop inside the material? How much you applied that only, or some additional value, some other value? How much field you apply, that much only we have to see. Ante kada? Here, how much electric field you apply, the same electric field we have to notice inside the body. But what Lorentz said that the electric field that you are going to see is applied field plus 3 P by 3 epsilon naught. This additional factor that we are going to find. Who said? How? For that purpose, right. I will take parallel plates connected to the source. What charge is going to develop? One plate positive charge, another plate negative charge. So, from positive to negative, the field is going to develop E1. Okay, right. Now, what we do? We introduce a dielectric material between the plates. Now, induction is going to take place. So, the side near to negative develop positive charge, and near to positive again another electric field is going to set up from positive to negative, induced field you can say it E2. Now, this substance, it is a solid made up of atoms. So, one atom will be there. What will be there? Atom, one atom I am taking. It is spherical. On the atom, again charges are going to induce. Negative means positive, positive means negative. Again one field is going to set up from positive to, that is E3. So, the total field that is going to set up how many? E1 plus E2 plus E3 plus E4. E4 with respect to the other atoms which are present in the substance. Other atom which are going to present in the substance is E4. So, total how many fields are there? 4 fields. What and what? E1, E2, E3, E4. Now, expression for E1 d by epsilon. The electric field E1 will be equal to what? D by epsilon. But what is D? Epsilon naught E plus P by epsilon naught. So, this equal to what? Epsilon naught E by epsilon naught plus P by epsilon naught. So, E plus P by epsilon naught. What it is? E1. Okay. Next, E2. E2 induced charges. Okay. Only polarization. And in which direction? With respect to E1, same opposite. So, we take minus P by epsilon naught. E2 value will be minus P by epsilon naught. E3 separation derivation is there for E3, but finally how much we get, you know? P by 3 epsilon naught. For that purpose, we take atom, we take a part of the atom, charge present, field setup, polarization, and finally some mathematics formulas are there. Hyperbolic functions. Idea on the mathematics lo. Cot HA. Chaptara cot HA. So, mathematics, by using mathematics, we are going to get final value of E3 which is equal to P by 3 epsilon naught. And E4, here E4 we assume as 0. Therefore, EI is what now? E1. What is E1? E plus P by epsilon naught. What is E2? Minus P by epsilon naught. What is E3? P by 3 epsilon naught. What is E4? So, cancel this. EI is equal to E plus P by 3 epsilon naught. Okay. Danish, can I get this on the screen? Possibility is there. సరిగా టైం అయిపోయింది అందుకోసమే ఒక్క నిమిషం ఓరియంటేషన్ పాసిబిలిటీ ఒక్క నిమిషం ఒక్క నిమిషం ఇది నాకు